Okay, awesome. I think I'm live here. All right. So, the plan for this live stream is to work on this project that I've been working on called EVM chess. So, essentially, what I'm working on is a smart contract where two people can play chess on the blockchain. So, and if they want to have like a wager, so like one player is like, okay, I want to play you, I want to play chess against you, and I want to bet $100, 100 USDC, or 100 or 1 ETH, and whoever wins the majority of X amount of games that they set, the person who wins would receive the money that they both bet each other. So one person creates a wager, let's say 100 USDC. Another person's like, okay, yeah, I'll take that. I accept those terms of that wager. They play some amount of games, and then whoever wins gets the prize money. So that's essentially what I'm building. So how have I implemented this? So essentially, you want to make sure that, so how would you verify that the people who are making the moves on the chessboard, they're not just randomly moving like a pawn to some random location? Like, see, there's a chessboard here. So how do we make sure that when a player moves, they're moving a valid move? So you can't just randomly move like your knight or whatever, some random position on the chessboard. So that's actually kind of difficult. So you actually have to write an algorithm that checks whether a move is valid or not. So how has this been done essentially? So you can think of a chessboard as an 8x8 matrix, and each piece on this chessboard essentially has a value. So a pawn in this case is a 1, bishop is a 2, knight is a 3, rook is a 4, queen is a 5, and king is a 6. And black pieces are all those values plus 7. And so yeah, so you can essentially encode a chessboard as a number. Any state of a chessboard can be encoded as a number. So there's this kind of interesting thing that I wrote here that so like we have this function called check game, and it takes an array of moves. So moves in this case are uint16 values. So a uint16 16-bit number has a max value of 65,535. So how is this encoded? Which is kind of cool here. So and forgive me, dude, I have not worked on this project in the past couple of weeks, so I might be a little rusty on exactly where things are in this repository. So I think it's in Move Helper. Where's a chess wager? Or is it in my tests here? I think it's in game test, yeah. Okay, so we have a board here, right? And you can think of this matrix, like I said, it's 8x8 matrix. And each square has a value from 0 to 63. So 64 squares, each square has a value mapped to it. So A1 is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So essentially that's how you can encode all the squares, and each square has a piece on it or it's empty. And like I said, so a pawn is like a 1, and other pieces have different numbers associated with them. So if you want to check, all right, so we want to move a pawn from d2 to d4. So I think that is 11 to 27. So this square here is 11, and this is 27. So you have two decimal numbers, so 11, 27, and in binary they are this. So it's 0, 1, 0, 1, 1, and 1, 1, 0, 1, 1. And what you can do, so you can actually concatenate these two binary numbers together, and you can store that as a single number as a uint 16. So you concatenate these two numbers together, and you can essentially encode the data. So like you want to move from 11 to 27, you take these two numbers, you concatenate them together, and you get this. And you know the first 8 bits of this number is 11, and then the last 8 bits are the second value. So you take this number, so this is your binary number, and you can encode it. So in hex, it's just 731. So you can pass, yeah, so, and then, like, so if you want to check a game, so all the moves in this game are, you can encode them as uint 16 values. So, and my move verification smart contract, so you can check game from start. So you can think of all the moves that are possible in a chess game. For example, all these moves. So, and these are actually moves in a different way. So you have like D2, D4, that would be this. G8, F6 would be G8, F6, C2, C4, C2, C4, and etc. And what I've actually done, so to make it easier, so instead of encoding all these chess moves as these, you know, low level, essentially uint 16 values, I've actually made it so you just input, this is called arithmetic encoding, I think. So like, it's like arithmetic notation. Yeah, algebraic notation, sorry. So A1, A2, like all, this is like how you can encode a chessboard with these arithmetic notation. And in chess, people actually don't use algebraic notation. They use different notation, but I don't know. So this is essentially just one way to encode moves on a chessboard. So it's no longer recognized by FIDA, but it's easier for a programmer to encode this as an algebraic notation. So what I've done actually is made it so that you can encode in algebraic notation pass this string value into the smart contract in this contract called move helper. So I wrote this function called move to hex. So you pass in the string, so like D2, D4 would be a string, and essentially it gets the first positions, first 2 characters would be the, you know, of the move, and the last would be like the second move, like so from the first square, that where the piece is, to the second square. This probably makes no sense, barely makes any sense to me, but and I wrote this a few weeks ago, so it's kind of, I'm just having a bit of a challenge trying to remember how in the world I wrote this. But essentially, like, you can encode this as like a uint 8 from positions, the first square to position, and then you pass this from position number to position number, and you get, so I wrote this other function called convert to move. Essentially, it's a bit shift by 6. So I'm actually concatenating, yeah, so I'm concatenating from position to position, and I get this uint 16 number, which is just the move. And then I take this move number, and I can go to my move verification smart contract, and I can pass in all the moves into here. So, and it can check all the states of the game. And so this is a mega contract, And I found parts of this on GitHub, but it was like written a few years back and it was in an old Solidity version. So now it's in Solidity 17. The newest Solidity version, if you're watching this in the future, it's actually, well, now the current Solidity version is 0.8.18. Current Solidity version is, 0.8.18, but I'm using Solidity 8.17. So this is really complicated. So I found this dude wrote this smart contract, and this is like a 1,200 line smart contract using all this bit shift stuff. And again, it was written this old, I think it was like written in Solidity 6 or 7. And the difference between Solidity like 6 or 7 and Solidity 8 is that integer overflow, if integer overflow occurs in Solidity 8, the transaction will actually revert. And the entire logic of all of this contract this guy wrote was the fact that he was allowing integer overflow and underflow. So in CS, you can actually think of a number so if a number overflows, like if it goes over past the max value, so if you have an 8-bit number and it goes past 255, it's actually going to wrap around. So like if you had the max value 255 plus 1, it would actually be 0, I think. Yeah. And you can kind of think of like integer or numbers in CS as like a speedometer, or like it's going to wrap around. So this guy wrote all of this to essentially assume that numbers wrap around. But when you're converting to Solidity 8, if there is integer underflow or overflow, it's going to fail. And trying to figure out where all that would fail in this contract, it's like a really long time. So like everything where I have unchecked, that's essentially I'm allowing things to underflow and overflow in here. So all right, so I kind of gave you an overview of what I'm building here. And to kind of give you another perspective here. So I wrote a very minimal front end. This is actually a template, but I've edited it a bit. So this is sort of what I envisioned. So you have like all these your users. You can connect to your MetaMask wallets. You can create a match. How many games you want to play, which token you're actually betting, USDC, DAI, ETH, or wrapped ETH, how much, the address of the other person, how many seconds per move. And again, this is like just a rough draft front end. So I think actually every time, so in the console here, yeah, I already made it so like you move, and in the console it's actually writing this algebraic notation of the move. So there you go. So then we'll have to pass every single time a player moves. We'll have to pass this move and pass it into our chess wager contract here. So we have a game. So like a game wager would be address of the players, address of the token, the amount of the wager, time per move, number of games, and if the person that has the other player accepted this wager. So, and then we'll actually have to save every single time a player writes a move, they have to write that move in algebraic notation to the smart contract itself. It'll be saved in the smart contract. And I'm sure there's another way how you could more efficiently save the value, this algebraic notation value in the smart contract. Like you use somehow like a ZK snark. I thought about like, how could you prove, like using signatures somehow to write. But then the question is like, where do you save all this data? So like I thought like it's best, easiest, simplest to just write the move into the smart contract. And then at the very end of the game, so essentially it's an array of moves. So all the moves that everyone's moved. And each time that a new move is made, it actually verifies it. So my contract, each move, it checks if that's a valid move. And then once the smart contract says, okay, yeah, it's a valid move, transaction passed, then it appends the newest move to the end of this move UN16 array. And then at the end of the game, it would check again all the moves, and if it passes, then whoever won that game, then it would be passed to here. So like number of wins, right? And then if the person has a majority of number of games, then they can withdraw the amounts that the two players decided on betting each other. All right, so I gave you an overview. Now, the question is, people can play. All right, so this is me on the stream here. Chess on the. All right, I don't want to listen to myself. That would be weird. Yeah, it's a valid move. Just want to make sure that this is working. Okay, so my goal is connect ERC20 functionality. User deposits. When user 2 accepts, they also have to deposit. Need to write tests for this ERC20 functionality. Need to test on localhost a bit, and if I have time, I'll maybe do some front-end stuff. Okay. All right, yeah, so all this stuff is actually private repositories currently. So yeah. I'll try to explain what I'm doing here. It's kind of hard to like code and like think about like trying to explain at the same time. But you know, it's kind of challenging. But this is the first live stream that I'm doing, so maybe in the future I'll get better at coding and talking about what I'm doing at the same time. So, all right. All right, so ERC20 functionality. All right, so this is my game test here. So you can print out the state of the of this 8x8 matrix essentially in like an ASCII position. So you get the moves, everything works. All right. Okay, so I have this token I need to deploy. Maybe I should do that at the top here. Oh my goodness. So this actually doesn't take any parameters on deploy, so I think I can just all right, so essentially all this is, like all these moves, I'm just like console logging. I think I'm console logging from actually inside the contract. Or I think I'm console logging here. Yeah, so I'm like doing a for loop essentially. Yeah. Converting it, move to hex from getting it from inside the smart contract. Passing in game address, because each game has its own unique address. And hex move, I'm also passing that in. And when I do chess wager, so I have 3 functions here, I think. So create game, start game, and then play move. These are just view functions here. Yeah, so okay. All right, no. All right, so we import token here. And this is actually, so wager token, I just set this as like 0 address. So let's, yeah, whatever. So wager token is it gonna be token dot address? I think that, yeah, maybe. All right, maybe I should. Okay, actually that worked. Okay, so that was, so I named this exactly the same thing. So it should create game. You know what? Yes, this is essentially the same test. I mean, it's like, I don't know what I'm doing. All right, so actually in the smart contract now, we actually need to so safe transfer thing is, do I have ERC, safe ERC 20? I think I do. Okay. IRC20. I think I do. Okay, alright, now. Thing is, I have to know where is IRC20, so yeah. So I think that's gonna work. Nice. Okay. All right, so when the person creates a game, they need to transfer the amount. All right, so will our test work? Probably not. But let's see where it fails. All right, what? So yeah, should create wager. We first have to approve, I think. So yeah, what probably happened here is that actually we're trying to transfer the 0 address, which makes no sense. Okay, so let's wager equal. Probably gonna fail again. Probably something else, to be honest. Yeah. All right, ERC28 transfer exceeds balance. So when I'm actually deploying this ERC20, I need to deploy it as deploy as connect as deployer. Yo, okay. Question is, who is the deployer? Because whoever is the deployer has like this amount of the token. Connect. See, that's what I was trying to do. So why was that not working? Dot connect deploy. Not signer, deployer. Oh yeah, because it's like red everywhere. I don't know why it's red everywhere. Yeah, I don't know why it says like it's an error. Still. What in the world? Okay. I don't know if that's a method. Okay, we're just gonna assume that it gets deployed. Well, console log there is the question. Yeah, maybe the problem's in here, to be honest. If I do this, then it's gonna be like token not defined. Yeah. Hmm. All right, so our deployer is this address. Where's this getting console logged? Yeah, this is really stupid here. Really stupid. I was passing it in as a signer, not the address. See, that's what happens when you don't work in Solidity stuff for a few weeks. All right. So, this is the balance. It's like some mega number. All right, so now what we got to do is I want to have both people, which is our deployer and the other account, they need to have a balance of this token. So what we got to do is this deployer, whoever mints the token, has all the balance, and they need to send to the other account. So that's, or they don't have to, but for the test's sake, why not? So token dot transfer from or to an amount, right? That's the method. So other other accounts, their address, not the signer, and an amount. So we could do, let's do comments amount is equal to ethers. Man, I always forget this, like the amount. Yeah, so this parse ether 1, so 1e18 is that. Okay. Okay. All right. So this other account should have 100 e to the 18 amount of that token. So now let's fix these other tests. So wager token, so hold up. Should create wager. All right, we're still at this point. All right, we have balance, we have that up. All right, will this other test work now? Well, the first test should create wager. All right, now should create wager is not working either. Wager token. So why is it not working? Transfer amount exceeds balance. Do I have to approve first? That's probably what. Wait though. Wait. Wager token. Where is my wager token? Camera died. Okay. So now. All right, now I got to figure out why in the world. Why in the world? So it's failing here. The ERC20 token says transfer amount is exceeding balance, and it's failing here. Question is, we know that the person who's calling game wager is the deployer, and we know that they have a balance of this amount, which means I don't know why it's failing. I think we have to approve first. That could potentially be or is it like transfer from? Yeah, it could be transfer from, honestly. Transfer from. So from to an amount. From. Yeah, I don't know. Wager token is not correct either. So from to. So from is message. That's sender. To is address. This amount is wager. All right, we'll see if that works. Probably not, but insufficient allowance. Okay, that's a good error because that means that we need to approve. So let's let transaction equal await token dot approve amount. No, it's address, so it would be chess dot address. And amount is, so this is the thing, you can approve the max amount or you can approve just the amount that you're transferring. Let's try first the amount we're transferring. So wager, but we need to dude, Vim motions is sometimes annoying. All right, so we're approving a wager amount. Oh, it passed. Okay, great. That's good. So, now let's get the balance of the contract. So balance 0. Yeah. Naming variables is coming up with good names for variables is kind of a challenge, but awesome. Awesome, it worked. Okay. All right, now we just need to fix these other tests. So it's the same exact thing here, essentially. Probably it's going to fail also because I didn't approve. Yeah, insufficient allowance. That's perfect. Okay. So same exact thing here. And again, we don't actually need this variable. We can just do a wait. But the thing is, so I set up this test so that it's not, each test is actually building on the previous state. It's not like some tests you can have it where each test resets the state of the contract, whereas this test, it's an iterative type of test where it's like a unit test essentially, where each subsequent test is actually building on the state of the previous test. So if the first test changed something in the state of the contract, then the next test is actually working with that same state. And that's not ideal, to be honest, because it makes the test slower, but at the same time makes it easier because you don't have to, each test doesn't have to be as long. So yeah. All right, so all right, all three tests should pass. Hopefully, we'll see. Yeah, awesome. Perfect. Everything's working. So each test now, at the beginning, the person who's creating the test is actually depositing ERC token wager amounts. But the thing is, so at the end of this test, see, I'm doing get game status. The thing is, so at this next thing I need to do, so this is this All right, so it should play game. So this test is only, it's creating the game at start game. So essentially when the other user calls the function start game. So it's checking require, challenge not created, if it, you know, it has to be, the challenge has to be created. Then this, we have to send this amount. So yeah. So that's the next thing I'm gonna be doing. How long have I been streaming here? All right, I've been going for about an hour. Okay, so I'm gonna take a coffee break. I'm gonna be back. I'm gonna just keep the stream going though. All right. All right. Yeah. I'm gonna set another time for an hour. That'll be the next coffee break. Okay, what is the status of everything here? So status. Connect ERC20 functionality. We're almost there. Usually that would take like 20 minutes, but if since I'm like kind of rusty with Solidity, I've been doing stuff in Golang recently, and kind of jumping back into this is a kind of difficult if you're not in the same repository every single day. All right, so now when the second user calls the function start game, they also have to deposit the ERC20 token, the wager amount. All right, should create game. And I think I set it up so where the first person who says create game wager, they actually have to move. All right, I think I have it so the person who creates the game or the wager is always going to be black pieces first. And the person who starts the game, who accepts the wager, is going to be white pieces. I think that's how I have it set up. If there's a better way to do that, there probably is. Maybe there isn't. That's sort of the status. All right. All right, stream's working, I think. Yeah, stream is working. So the first move, this person is accepting, e2, e4, moving their pawn. But now, they sent. And also, so when the person, let's say the person doesn't accept, if the person, so if this Boolean that I have here for has player accepted, if that is false, and I think it always knits to false in Solidity, hopefully. Probably. If it's false, that means the person who created this, they can withdraw their deposit, the wager that they first sent. So yeah. So now we need to do safe transfer, and I think we already have, yep. All right, so why is it called wager address? Actually, no, wager address is, yeah, that's the name of the actual wager address. So each wager has a unique value to it. So it needs to be wager token dot safe transfer from, and I use safe transfer from here. Safe transfer from. Probably everything's gonna fail. Yep. Okay, so game address. Yo. Why was this working just a minute ago? Wager address. Oh man, the sun's coming out. Wager address. Safe. So yeah, from to. Yeah, so. Should compile. Hopefully will compile. Yes. But tests don't work now. Insufficient allowance. Yeah, so the other user actually has to approve as well. So when they call the function start game, they also have to approve the wager amount. So await chess approve. Oh no, token dot approve chess dot address wager, and this needs to be the same exact thing everywhere. So create game wager, start game, right before start game. Yeah. Will it work? Nope. We gotta connect as other account. Yeah. Okay. So other account. Hmm. Oh my God. Will it work? Oh, 2 passed. All right. So why is this working here, but it is not working here? Insufficient allowance. Why is it insufficient allowance? So token, connect, other account, approve. Let's do just some random. Wager is a string though, right? God. Or it's a big int. Big int. What's the method to check on ERC20 if check the balance, like the approval? All right, these are right functions. I need a view function. Allowance. Yeah. So console log allowance await token. Nope. Console log. Yo, no. So other account dot Classic. Console log here. Alright, what in the world? Why is it not even console log here? My question. Console log here. Should play game. Alright, should create wager. Boom. Should create game. Here. Now should play game. Actually, I think I lied. So like probably like 30 minutes ago, I said that these tests are iterative. They're actually not, because I'm using this load fixture thing. Okay, so absolute classic when you use console log here. Yeah. All right, so it's failing somewhere. Probably failing right here, but you know. It's probably some really stupid error. This is like always, where it's just like some. Okay, actually, it's failing before there. Is it failing in create game wager? Oh yeah. Again, stupid. So since these tests are not iterative, that means that each subsequent test is a clean slate. And I just forgot to do that, I think. And since there's no connect here, yeah, it worked. Okay, so, which is kind of sketchy because in ethers, hard hat ethers, when you just have token without a connect, it's like it's the first address that's in the list of addresses that you can use on your local host. So since that first address is just always ends in this 266. So, all right, so I think that all worked. So now what we got to do is the person who wins, person who has this. So if it's inconclusive, no one can withdraw. If it's a draw, the thing is like it has to be multiple games. Right now we're just testing one game. We need to have like minimum of 3 games, I'd say, or minimum of 3 games, like best of 3 games. So yeah, let's set a minimum here. So it's actually, that would be in create game wager, number of games. Let me set a require here. Number of games must be greater than or equal to 3. So the longer your error messages are on these requires, it's actually, if you have a like super long, like if it's this production, dude, you just have like 2 letters, and then in your documentation would be like, you know, yeah, that's the error. But so the longer your error message is, it creates a larger contract. But also, if it reverts, it wastes more gas for the user. So let's say the user had, you know, when they call this function, they actually put 2 number of games, like 2 games, then this would revert. And if this is like some super long thing, then it would cost more money for them, more ether. But for, you know, like a dev version, it's totally fine if you have long. But if it gets too big, if your contract gets too big, it's really annoying, because in the first place you got to start, you know, trimming down your contract is probably these required things. So will that compile? Hopefully. And probably the test will pass too. Yeah, perfect. Because our number of games is 3. See? Perfect. Awesome. So if it was that, everything would fail. One symbol makes everything fail. Cool. All right. Okay. What do we have to do? So connect ERC20 functionality. User deposits. When user accepts, they also have to deposit. So we have this pretty much. And we're sort of, so we did number 1. Now I gotta do some extra tests here. All right, so I gotta write to this thing. So this is a Solidity task, not a TypeScript test unit test task. Get game status. Okay, so if outcome, so I gotta keep track of white player pieces and black player pieces and have to keep track. So each new game has a switch, right? So you don't want people always playing white pieces and you don't want someone always play black pieces. So all right. This is a view function. We need to like have a So when I do play move, this, I need to call get game status, and then that means I need to it's not ideal. Okay, so the user calls play move. It's an external function. So if the user is not, it's not their turn, it's going to revert. Where's my get player move function? Okay, so get player move. So if they won, I think we have to call this other function called update player or update wager state. Yeah. All right. So I mean, ideally on this play move. Oh wait, that's what happens automatically. So hold up. So when play move is called, right here, it goes to update wager state. And every single time we're calling check game from start, which is not good because as there's more moves in a game means that the game actually gets more expensive gas-wise. But again, that's okay. This is like optimization stuff. We just got to get this thing to work. That's the main focus. Then we worry about optimization, gas optimization, all that. It just needs to work. And if it's on Polygon or some other like chain, that's not like, you know, mainnet Ethereum, then it's not going to be that expensive anyway. So that's okay. It's fine. All right. So every time play move is called, update wager state is called. And you know what? I'm gonna do this. Okay, so if outcome is 0, it's gonna return false. Why is it returning false? What was my plan here, to be honest? All right. So if outcome is 1, wins player, so that means it's a draw. They both get a win. Yeah, they both get a win. Or should that be 0? I don't know. Maybe that should be 0. But if outcome is 2, that means the white player won. White pieces player won. If is player white, if that's true, okay, then they get a win. If they're not white player, that means they're the black pieces. Okay, so player 0. If player 0 is white pieces, then they get a win. If they're not, then they get that. And then the same for here. All right, wait. So this should be if this is false, right? So if 0 player 0 has white pieces, this is true. That means the other player, the black pieces player, gets a win. Now let's say player 0 is not white, so this returns false. That means they get a win. And then we update who's the player. Next player is the opposite of what they were. Dude, when I read my code back, like I wrote this probably like 2 or 3 weeks ago, and I look at this, I'm like, what in the world, dude? It's kind of like, it's kind of funny. It's like, I actually wrote this. It's like, yeah, I can barely understand what's going on sometimes. Well, I understand it now when I like walk through it, but all right. All right. So, does the game state get updated though? So we have this game. Wait, your address. All right, so game ID needs to get updated. Game ID needs to get updated. So we got to push to game ID. Probably here. All right, so so we have this thing called game IDs. All right, uint. Again, not ideal from a gas standpoint, but that's okay for right now. And the camera died. All right, so push. Or what should I do is just yank that. Oh my goodness. The camera's dead, so I'll have to. Camera's gonna be dead for a while. It'll turn back on, but whatever. All right. So, or actually, I do have a. Let me fix this one thing, and then I'll worry about camera batteries. All right, length. Game IDs, major address. All right. If that compiles, that means that I can get a new battery. Oh, perfect. 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 All right. Back in business here. Let's make sure that stream is working. Nice. All right, cool. All right, so this compiled. Okay, so essentially what's happening here is this is an array of game IDs, and it's mapped, so wager address is mapped to game IDs, which is just literally an array of number of games. So we can map how many games, number of games, are in this wager address. Yeah. And if player wins, whichever player wins, if the status is it'd be 1, 2, or 3, we need to then update the game ID, or the length of the game ID. So we need to add this to all of these here. Oh. All right, so invalid moves, which means, what does that mean? Oh yeah, so, oh, okay. So, that means that in our test here, we are using all these moves, and once it gets to here, so essentially what happened is once it got to this last move, it reverted because our game ID is now different. So think in play move, the function play move, we need to check. Oh yeah. So we're already checking the game ID. But it's what? 1486. I think is that. What's console log? Alright, this is gonna be a console log mess, but I want to see what the last move is. I think it's this. Yeah. And invalid moves is, I know, is only in move verification. Oh, no. Okay, require moves.length to be greater than 0. Okay. So you know what? It's probably this. This is what I'm thinking. If I change this number 1 to 0, I think everything will work. Maybe. Maybe. That's what I think. Oh, no. Okay. Something's wrong here. Why is it not your turn? Why is it not your turn? All right, so where am I moving D2, D4 in my test? First move. All right, so when you call start game, you have to pass in the first move. So probably not gonna work. Nope. Invalid move color. You know what I should be doing at this point? I'm not saving any of my progress. Not saving any progress here, which is not good. Okay, great. Yeah, everything updated. Awesome. Okay. Okay, so this final move is not working because I think it's getting to the end of this array of moves. And it's essentially, the game has been reset. So let's get rid of these console log here's. Yeah, this probably won't work because then the last move won't get included. It's gonna pass probably, but yeah, game status inconclusive because this last move, this is checkmate at this point. All right. So what this means is that we're calling check game from start when moves is equal, the length of this is equal to 0. That's what's happening. Test that theory. And the last one should be 1. That's my hypothesis. No, it's not. It's not 1. right, so 49 moves. But at some point, moves is equal to 0. Yeah, length of moves is 0. Nice final call. So it's going, so final thing is here. Again, my D is 0. Size is 49. Then we're reading through all this. Boom, 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 boom. Calling update wager state. Then it's going to check game from start, and check game from start. That's where we're getting that no, that's not true. Okay, so then we're going to check game from start, which is here, this function. Then this function in its return statement calls this function. Then here, that's where we're getting this 50 number, 50. Which then, it passes, and it does all this, called all this, and then this whole thing gets run. Okay. Let's go back. Okay, so wait. Let's go over to test. All right, so then we're console logging our move. Then we console this. Then we call get game status. Yeah. Because get game status, yeah, that's what's happening. So we're calling get game status. If I comment everything out, it'll probably work because we're calling get game status, but the game ID has been increased by 1. So when we call get game status, it's trying to check the game, yeah. But since player 1, we increased the game ID by 1, and then we're calling get game status, but since get game status, the function, is looking at the current game, no moves have been played, so that's why we're getting, because the array is empty, and then we're calling our function verify the, check the entire game, but since we don't have any moves, so that's where we were getting the error. So now we got to finish this test though. So the test needs to check So this was, yeah. So the black piece is 1. So let's call the chess wager function, and let's actually call and see. We're gonna see which. So yeah, we gotta call wager status. So wager status address dot wins player. That's what we gotta check. All right, so let wins player 0 equal await chess dot wager status. Since this is a function, oh wait, but this is a mapping. I don't know if we can call a mapping like this, but we're gonna try. So it's gotta be the game address. So the reason why it's kind of confusing, because everything's called game address. When I was first writing this, everything was like, I thought each game it's gonna have its own address, but then I realized you want to have players play multiple games. So then I changed it to wager. Each wager has its own address. So that's why in the tests, like, it's called game address, when the games actually don't have their own address. The games have an ID, which that ID is in an array, which that array is linked to an address, and that address is called the wager address. So kind of confusing. So wager status. Wager. No. Game address. We're gonna have to change this. This is really annoying. Okay, so maybe we should write a view function. Yeah, we're probably gonna have to write a view function, because this probably won't even run, to be honest. So log, but it's not gonna even be wins player. It's just gonna be the whole struct that's connected to this address. So let's just do wins. Let's call it wins. And let's get rid of all these console logs, because that's going to drive me insane. And in our contract, we have a ton of console logs as well. So chess wager. All right, yeah. Okay, so wins player 1 is 0. Perfect, it worked. Okay, so initially this should be false. And then so player 0 is now white. Perfect. That's exactly what I expected. So the player who creates the wager starts as the black pieces. However, each subsequent game they have to switch, because you don't want the same person playing the same pieces all the time. So this inits to false, then it switches. Perfect. Okay, so let's do wins dot wins player 0. All right, I got to get rid of all these console logs. All right, yeah. So 1. Is player 1, but the black piece is 1, I thought. So player 0. Yes, so the person who creates the wager is the black pieces, and that means player 0 is the black pieces, which means player 0 won this game. So that's correct. Okay. Alrighty. So so wins Let's not. So const wins player 0. All right, so we're gonna write it to expect. So, how do I convert a big int to? I think you just wrap number around it, right? Yeah, the console logs. Oh yeah, so 1. Perfect. Okay, so okay. All right, so technically we should take a coffee break, but kind of don't really need a coffee break. Set the timer again though. All right, so I think I'm at like 3 hours actually, but hold on, let me finish this functionality and then I'll figure out what in the world's going on with the stream. So expect wins player 0 to equal 1. Expect, oh my god, expect. Wins player 1 to equal 0. Let's get rid of console logs. Time to get rid of console logs. So log all this junk. Move verification. Gotta change back these view functions to pure functions. Compile, yep. All right, compiled. And these are all the moves. And this should pass. Yep. Let's console log it too. Console log wins 0. All right, cool. All right, so this test is super annoying. So essentially what I got to do again, and this test is going to be super long, is when the next game starts. So player 1. Now you have to check. You have to check if the game is this number equal to the majority of number of games that they're playing. That's essentially what we gotta check. All right. Anyways, get commit, feats, player wins. All right. Yeah, I don't know what's going on here. Yeah, I'm still live. Nice. Okay. All right. So, to be honest, I'm probably going to end the stream there. It's a good test of a good first stream. Got some functionality going. Tests are passing. Everything's working, sort of. So, what did we accomplish? Let me do a quick recap in this stream. What in the world did I accomplish? I accomplished a connected ERC20 functionality. User can deposit. When another user accepts, they also have to deposit. That works. That currently works. I wrote some tests for functionality. Also, when the other user, when a user wins or loses, so like when one player wins, we actually write that to the state of the smart contract. So like in here, this game wagers, this is updated. This wager status struct gets updated. This struct is actually mapped to the address of the wager, not the game. And probably the next thing I gotta do, maybe another stream. I'll probably, this will be updated, but so player, so let's say number of games is 3. If one of these values is equal to 2, the majority of number of games, then automatically the wager, and I have to have some sort of like bool is ended, has been paid out. The camera died again. That's a good sign to finish up the stream. So, if one of these values is the majority of number of games, that means that means the wager has been won, and whoever has the higher number, they can actually withdraw the value. So that's for another stream, or I'll do that on my own. But again, the vision for this, why in the world am I doing this? It's a good question. I'm doing this because one, it's cool. The fact that you can play chess on the blockchain, it's pretty cool. And the fact, this is like a perfect example of why smart contracts exist. Essentially, it's a mediator between two parties. And two parties agree to some sort of contract. They're playing chess. Whoever wins, and the smart contract can verify whether the player won or not. And whoever wins the majority of the games, that's the person who can withdraw and they win the wager. So the vision for all of this, again, I want to create a simple interface like this. This works. I just don't have MetaMask in this browser here. Like, I think if I do console log here, it'll actually show when I click this. Oh yeah. So like here, yeah. So The next step is to actually, every single time a user is moves, we have to pass that into, see that was an invalid move, perfect, on the front end. We have to pass that and write it. So MetaMask will pop up, you sign the transaction, you send the transaction, we'll write your move into the smart contract, and that's how that would work. And then we can interact with our smart contract. So user would be able to create a game. You'd be able to see challenges. That's another thing. So I'd like to see, so like you can create a challenge for like anyone, essentially. And people can accept the challenge. Like, okay, yeah, I see someone wants to play a number of games. And if you accept, then the game would automatically start. The only problem with this whole thing that I see is how would you prevent people from cheating? That's sort of my question. So I thought like you could have like a reputation and like a status. And you could filter by status, you could filter by like reputation, number of games, wager amount, blah, 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 blah. So, all right, so that's probably, I'm gonna end the stream there, but that's what I'm building. It's just a good experience building in Solidity, all this stuff. It's kind of like a pet project. So anyways, that's gonna be it probably for the stream.